So the points A, B, and C were given, except for in B, we're missing an X value. And we're told the angle ABC is 90 degrees, and we need to, for part 1, find the value of B. Right? When we have an angle of 90 degrees, we know something, we know the angle. We also know about the two lines that they have to be perpendicular to each other. And when we're talking about lines, we know something about the gradients of perpendicular lines. The gradients, there's two things. They either multiply to -1, or one gradient is the inverse negative of the other. So that's what we should do to try and work out B. We should say the gradient of AB is perpendicular to the gradient of BC. So to find the gradient of AB, we're going to do change in y over change in x. So we'd take 3 minus 1 divided by b minus 2. And we're going to use the multiplication version of the formula. So we'll multiply by the other gradient, which it doesn't matter which order you put the point 1 and point 2. So I'm going to take the b point and put it first and subtract the c point. So the y values are 3 minus 5 and the x values are b minus 5 as well. When they multiply together, because they're perpendicular, it equals -1. Okay, we want to simplify. 3 minus 1 is 2 and 3 minus 5 is -2, so we have 2 times -2 divided by, let's put it in brackets because they are being multiplied, b minus 2, b minus 5, and of course that equals -1. Let's take the denominator of the brackets up to the other side and we'll get 2 times -2 is -4, and it comes over, the negative sign gets to stay there, and we'll have b minus 2, b minus 5. Let's leave it like that for the moment. But what we should notice is both sides have a negative, so we can multiply by -1 to get rid of that, and we can then expand the brackets. I'm going to expand the brackets and just put it on the left side. And so we'll get b squared minus 2b minus 5b, and you put them together, you get minus 7b, plus 2 times 5 is 10, -2 times -5 is also positive 10. And that equals 4. Remember, we made both sides positive. Okay, bring the 4 over, we have a quadratic. B squared minus 7b plus 6 equals 0. We're looking for two numbers that multiply to 6 and add to -7. The two numbers are -1 and -6. So we can rewrite that as b minus 6 in brackets times b minus 1 in brackets equals 0. We use the null factor law now to say the solution is b is either 6 or b is equal to 1. But the question told us that b is greater than 3. So b can't equal 1. And the answer is b is 6. And when b is 6, the point B is going to have the value of 6, 3. For part 2, we're asked to find the lengths of AB and BC. Well, the length between 2 points, point A and point B, is just the distance, which is, we have a formula for that, the distance formula. This formula, of course, comes from Pythagoras' theorem, where we make a triangle, and the x values are horizontal, the y values are vertical, so they make a right angle triangle, and that's why Pythagoras' theorem works. The distance formula is the square root of the change in x, x2 minus x1 squared, plus the change in y squared, which is y2 minus y1 squared. If we want to find the distance AB, we're going to take the x values. So let's take the x of b minus a, and we'll get 6 minus 2 squared plus the y values 3 minus 1 squared. 6 minus 2 of course is 4, squared you get 16, 3 minus 1 is 2, and you square it you get 4, 16 plus 4 is root 20. We end with root 20, which is approximately 4.47. To find the distance BC, we're doing exactly the same thing. In this formula, it doesn't matter which point you put first, because when we subtract, either way, you'd either end up with positive or negative. But the squaring makes the answer positive, so it doesn't matter at all which one we put first. So I'm going to put B and I'm going to subtract C. So for the x values, I have the square root of 6 minus 5 squared plus the y values 3 minus 5 squared. 6 minus 5 is 1, square root you get 1, and 3 minus 5 is -2, square root you get 4. 1 plus 4 is 5. So the answer for the distance BC is root 5, which is approximately 2.24. I think at this point it may be worthwhile getting a graphical understanding of what we've just done here. So if we have a a Cartesian plane and we put on the point A at 2, 1, and we put on the point C at 5, 5, and B had the limitation that the y value is 3, so it's anywhere along this line of 3, and it can be anywhere there. But what we do know is the angle is 90 degrees, and so as B moves along, it reaches 90 degrees in a couple of places. From our calculations, we know that will be 1, but it can't be 1 because of the restriction the question gave us, and so we would come to the other point where the angle is 90 degrees, where B is 6. Now the part 3, we get to the point of the triangle, and if you look at the triangle, it's got a 90 degree angle in it, and so the way you find the area of a triangle with 90 degrees, you can treat one of those sides as the base and one as the height, and the area is just a half of base times height. And so in this case, we're finding a half of AB times BC. But these are two distances we just calculated in part 2. So the question is simply a half of root 20 times root 5. The two roots are surds. They can come together as a square root of 20 times 5, which of course is 100, and a square root of 100 is 10. So we have a half of 10, which the answer is 5 for the area of the triangle ABC.